Alright, so in this problem, I have 4 to the power of x is equal to 8. So I want to find the value of x. For my solution, first start with 4 to the power of x is equal to 8. And 4, this is the same thing as 2 to the power of 2. And 8, this is the same thing as 2 to the power of 3. So now if I replace 4 with 2 to the power of 2, and if I replace 8 with 2 to the power of 3, I get 2 to the power of 2 to the power of x is equal to 2 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is simply equal to a to the power of m times n. So 2 to the power of 2 to the power of x, that's going to equal 2 to the power of 2 times x, which is simply 2x, which is equal to 2 to the power of 3. Now, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, 2x is equal to 3. So I have 2x is equal to 3, so I'm simply going to divide both sides by 2. These two cancel out, and I'll be left with x is equal to 3 over 2. So this is my answer. Now, there's actually a second method of solving this problem. So again, I first start with 4 to the power of x is equal to 8. But this time, I'm going to take the log on both sides. So now I have log 4 to the power of x is equal to log 8. Now, if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times log a. So in this case, for log 4 to the power of x, I can move x to the front. So that's going to equal x times log 4, which is equal to log 8. Now I can simply divide both sides by log 4. These two cancel out, and I'll be left with x is equal to log 8 over log 4. Now, remember 8, that's equal to 2 to the power of 3, and 4 is equal to 2 to the power of 2. So now I have log 2 to the power of 3 over log 2 to the power of 2. Now I can move these exponents to the front. So now I have x is equal to 3 times log 2 over 2 times log 2. These two log 2's can cancel out, so I'll simply be left with x is equal to 3 over 2. So this is my answer. Alright, so for this problem, I have x is equal to x over 2. So I want to find the value of x here. So for my solution, first start with x is equal to x over 2. Now I'm actually going to subtract x over 2 on both sides. So then these two x over 2's cancel out, and now I'll be left with x minus x over 2 is equal to 0. Now I'm going to multiply both sides by 2. So now I have x minus x over 2 times 2 is equal to 2 times 0. So for 2 times x minus x over 2, I'm simply going to distribute the 2 to all terms in my parentheses here. So first off, 2 times x, that's simply equal to 2x, and 2 times negative x over 2, the 2 simply cancel out, so I'll be left with is negative x. And this is equal to 2 times 0, which is simply equal to 0. So I have 2x minus x is equal to 0. Now 2x minus x, that's simply equal to x. So I have x is equal to 0. So x equals 0 is my solution. Now I actually have a second method of solving this problem. So again, I first start off with x is equal to x over 2. And now this time, instead of subtracting x over 2 on both sides, I'm actually going to multiply 2 on both sides. So I have 2 times x is equal to x over 2 times 2. Well, 2 times x is simply equal to 2x, and x over 2 times 2, these two 2's cancel out, so I'll simply be left with x. So I have 2x is equal to x. Now, I'm going to subtract x on both sides. These two cancel out, and I'll be left with 2x minus x, which is x, is equal to, on my right-hand side, I'll have 0. So x equals 0 again. So now to check, I have x is equal to x over 2. We know that x equals 0. So I have 0 is equal to 0 over 2. 0 divided by 2 is 0. So I have 0 equals 0. And because this is right, my solution is right. Alright guys, so in this problem, I have 2 to the power of 20 minus 4. So I'm going to first start by rewriting 2 to the power of 20 as 2 to the power of 10 times 2. So I have 2 to the power of 10 times 2 minus 4. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 10 times 2, we can rewrite as 2 to the power of 10 to the power of 2. Now I have this minus 4. 2 to the power of 10, that's equal to 1024. So now I have 1024 to the power of 2 minus 4. And 1024 I can rewrite as 1000 plus 24. So now I have 1000 plus 24 to the power of 2 minus 4. Now if I have something in the form a plus b squared, this is equal to a squared plus 2ab plus b squared. In this case, a is equal to 1000 and b is equal to 24. So I have 1000 squared plus 2 times 1000 times 24 plus 24 squared. And then I have my minus 4 at the end. Now 1000 squared is equal to 1 million. 2 times 1000 is 2000. 2000 times 24 is going to be 48,000. Now 24 squared, that's going to equal 576. So I have 576 minus 4. And 576 minus 4 is 572. So I have 1 million plus 48,000 plus 572. And this is equal to 1,048,572. So this is my answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this problem without a calculator. So we have 200 squared minus 199 squared. And a lot of you there might be thinking, well, how are we going to do this without a calculator? These numbers are so big, and squaring them, that would create a number so large that it would be really challenging to do on paper. Well, there is a simple trick to doing problems such as these ones. So if you recall, a squared minus b squared this is an important expression in algebra, and this is actually equal to a plus b times a minus b. So a squared minus b squared is equal to a plus b times a minus b. So all we have to do is plug in 200 and 199 for a and b. Well, we could say that a is 200 and b is 199. So, meaning 200 squared minus 199 squared, this is equal to 200 plus 199 times 200 minus 199. Now, 200 plus 199, that's going to be 399. So now we have 399 times 200 minus 199. Well, these two only have a difference of 1. So we simply have 399 times 1. And this is really simple. Anything times 1 is itself. So this would simply equal 399. Meaning the answer to this problem is 399. And it's that simple.